Hey everyone, this is Andy Melbuff, and in this video we're going to explore how we can restrict the graphs of equations in Desmos Activity Builder by restricting domains. Many of us are very familiar with the Desmos graphing calculator, using it individually or using it inside of Activity Builder. So I'm going to show you this inside of Activity Builder. In this slide, we're looking at the graph of a linear equation in red with a slope of 2 and a y-intercept of -3. But we do not see all of that equation being graphed. We only see a portion of it being graphed, and that's due to a domain restriction. So following my cursor here, I'm highlighting how we put in a domain restriction. Inside of curly brackets, we tell Activity Builder, we tell the grapher what values of x to use. So in this particular case, we're using x values less than or equal to 4. So we're going to see the linear equation graphed as long as the x values from that equation are less than or equal to 4. So basically that gives us a linear equation that stops at an x value of 4. If we want that to go a little further to the right, we can increase that restriction of 4 and maybe put it at 6. And now our graph will go up to 6, up to an x value of 6. We can change how we want that to graph if we turn it around and say, I want x values greater than a certain number. So I could certainly use greater than or equal to 5. And then we see the portion of that linear equation from 5 on higher. So that's called a simple domain restriction, and again, format-wise, we must use curly brackets in there. So I'm going to turn this line off and show you another graph. This one's a parabola with also a domain restriction. I'm going to move this over just a little bit, and here we can see a parabola with the right-hand portion graphed and some of it on the left graphed. And here our domain restriction is x greater than -5. Notice I left the equal sign off. I haven't noticed any visible difference whether you use an inequality with an equal sign or not, but basically we see a portion of this parabola graphed. And again, I can change. I can make it x less than a number. And here we're graphing where x values are less than 4. Now I have to zoom out a bit, quite a bit, so that we can see where this stops at an x value of 4. And that's going to be undefined at that point. So all the other points on this parabola less than 4 are being graphed. So I'm going to take you to the next screen and show you a domain restriction for a trig function, or a trig equation. In this case, y equals sine x. Now y equals sine x should run indefinitely from left to right, moving up and down, fluctuating with its appropriate amplitude and period. This one stops at pi over 2, and that's because we put in a domain restriction here of x less than pi over 2. So to show you how to get this in, I'm going to take this out. And for those of you unfamiliar, we can get the pi symbol by just typing pi, and then I can divide it by 2 to make that fraction. And again, I can change this restriction. I can have it go further to the right by changing my ending value of 3 pi over 2, etc. Now, we can also make this have a beginning point as well. So we can make a double inequality, if you will. So if I want this to run from negative pi over 2 to 3 pi over 2, I can put this part in. Negative pi over 2 less than x less than 3 pi over 2. And now we see here in our graph just that portion of the sine wave between negative pi over 2 and 3 pi over 2. So I want to take you now to a short build along where we're going to put one of these slides together. So what we're going to need for sure is a graph component. So on my left-hand side are my available components, and I'm going to choose right now to use just a full screen graphing calculator like we just saw. So I click that. That's the only component I can put on this slide, and then I need to decide what type of equation do I want to have in here. Well, I can use function format, I can use equation format, it doesn't matter. So I'll change it up this time and go to function format, and let's try an absolute value equation. So I can get my vertical bars by using shift and then it's the key right above the enter sign. That'll get me my vertical bars, and you can see here a V appear, and so this absolute value just keeps going and going and going. It has no end, but then we can restrict. So let's say I want to see values less than or equal to 5. I use curly brackets, and inside of the curly brackets I type in x less than 5, and there it cuts off or restricts the graph of this to just values below 5. If I want to put an equal sign in there, I can put my cursor right after the inequality and press the equal sign, and it inserts it right below that inequality. And now this should be defined if I click on 5. If I don't have the equal sign in there, it should be undefined at 5. But visually it looks to be the same. So again, if I want to make it a double inequality, I can do so in this manner, and now we just see a very small portion of that V that we had originally. One of the nice things about restricting domains is we can put multiple domain restrictions together to create images on a graph. Now, this particular graph has 4 different equations being graphed, and each of them have domain restrictions. Now, I left them as different colors so that they would stand out to you when we talk about what each of these are. Now, this first one in red is simply a linear equation, but I'm restricting it to be between x values of negative 2.193 and negative 1. Well, why are you coming up with negative 2.193? That's because I knew that this red line would intersect this purple parabola at negative 2.193. So knowing that, I set that as my lower limit for my domain restriction. If I take out this domain restriction, I see the entire linear equation in all of its domain being graphed. And you can see right here, if I click on this point, the point of intersection x value wise is negative 2.193. So I'm going to paste this back in so that we're where we started. My second equation is also linear, and it just has an opposite slope. That's the blue one that you see there. If I take its domain restriction out, there's the entire blue line, but I don't want to see all of that. I just want it to be basically the side of this image that I'm creating. The image isn't anything, it's just made up. So I'm going to paste this back in, and the green line, it looks like a line segment. It's actually a horizontal line going through a y value of 2, but we're restricting its domain to be between negative 1 and 1. And lastly, I have my purple parabola here with its domain restriction. Let me drag this over just a bit. If I were to take that domain restriction out, there's the entirety of the parabola. But if I just want that certain image there, I can restrict it, paste that back in. And again, all points here on this graph can be clicked on to be viewed, etc. The last example we're going to look at involves a domain restriction, this time in a graph component that's not a full screen grapher. So this might be part of an exploratory activity with students, and I want to show you what it can look like in preview mode before we look at the behind the scenes part. Now what I'm hovering over here is the graph component. Notice it's not full screen, so the students can't interact over here with anything. They just get to see this. So what they see is a part of a parabola. This is a parabola opening down, and they only see the right-hand part, and this can be used to simulate the height of an object falling from a certain initial height, in this case 400 feet. And also here is an action button. And this action button is tied into the graph in a way that when the button is pressed, this point will start following along the path of this parabola. So let's take a look at it. The first coordinate is the x value, the second coordinate is the y value, and it basically shows the path that this object takes when falling. Now when it stops at 5,0, that indicates it takes 5 seconds to fall to a height of 0. And up here where we started, if I click on that point at a time of 0, it's 400 feet high. So let's look behind the scenes at how we put together a slide like this and how the domain restriction impacts it. First of all, on this slide, I've got a note component, and all it has on there are the directions. I also have an action button component that's right below the note. Now I've named this button, this action button, because we're going to tie it into this graph with a short piece of computation layer that we'll get to in just a moment. But first I want to show you what's in the graph. So I'm going to click on Edit Graph, and here is the function that I want to have graphed. That's the parabola with the initial height of 400. Now you can see after it in curly brackets we have a domain restriction. I want this to go between 0 and 5. And I chose 0 because that would indicate our starting point up here, and I chose 5 because that's when it would simulate hitting the ground. If I take this domain restriction out, here's the entire parabola, but I don't want to see all of that because it's not relevant. So I'm going to put that domain restriction back in, and now we see only the portion of the parabola relevant to this object's falling flight, if you will. Then next what I have is a point right below it. Now I chose to label this as P equals. You don't even need the P equals. But nothing shows up because right now Activity Builder doesn't know what an x coordinate of A is. And if it doesn't know what A is, it can't evaluate f of A. So it says put in a slider. Well, let me show you what happens if I click on this to add the slider. Now right now when adding a slider, it starts out at a default of 1. And you can see here, there's my point on the function 1, 384. And as I advance the slider, you can see the point moving along here. And that's all great, but the student can't get to this slider. So what I'm going to do is I'm going to take this slider out, and instead of a slider, I'm going to define A in the computation layer. So I'm going to click Done, and here's the computation layer script for this graph. So entering this, and for those of you unfamiliar with computation layer basics, I encourage you to watch some other videos, but I'm going to define the number A, and this is the format we use. We use backticks surrounding A, and then after the colon, this is called a sync, this is a number sync. After I define the number A, well, what's it going to come from? It's going to pull from the button component the source of time since press 5. What that means in layman terms is once the button is pressed, A becomes a timer, and it's going to count from 0 up to 5. We're creating a 5-second timer. And I used 5 because I know that's how long it's going to take to fall to the ground. So previewing again, right now A is not defined because the button has not been pressed. Once I press the button, A starts counting from 0, and you can see the values here of A, until it gets to 5, and then it stops right there. So for those of you unfamiliar with computation layer, let me show you how to create this maybe from scratch. So I'm going to take all that out, and I start by, I have to define the number A. So I start typing number, and as soon as I get the N and the NU, here are the possible choices I can use in my computation layer script. So I'm going to use the number sync. It prompts me already with these backticks. So I just need to know what to put in them. What number am I defining? Well, I'm defining A, so I'll put that there. Then after the colon, I need to tell it which component to draw from and what's the source of that information from that component. Notice right now I got this little warning triangle. It's saying this isn't working yet. You haven't completed what you need here. So the component I'm going to use, I've named button. So as soon as I type B, I get button. It says alias. That's the component it recognizes. Then I separate the component from the source with a period, and here are the possible sources I want to choose from. And I choose time since press. Now, if I don't put anything in the parentheses, this number A will run for 10 seconds. 10 seconds is the default. But if I want to shorten that or lengthen it, I can put a number in the parentheses, in this case 5, to enable that to happen. So one more time in preview mode, once the button is activated, A will count from 0 to 5, and there's our simulation. So that's an introduction to how we can create limited graphs, if you will, using domain restrictions in the Desmos graphs.